everyone for coming. People actually came. That's good to hear. There's very little Kotlin in the name of my talk in a Kotlin conference. I actually spoke about Datomic at a Scala conference in April, and I've never written a single line of Scala in my life. But Kotlin I'm actually using, so I feel a little bit more at home here, maybe. But there's one thing you have to get out of the way before I sort of get going, which is that Datomic, it's a database, but it's not only a database, it's a proprietary database. And from time to time, people can get confused whether or not I'm actually associated with the company making this proprietary database, which I am not. I am just a happy user. But I do feel like I'm sort of as official as it gets, because this happened actually a couple of months ago. They follow me on Twitter now, so yeah, thank you very much. Thank you. So I guess maybe I showed up in their invoicing system or something. Like people said, there was this guy from Norway who talked about Datomic. That's how we heard about it. So anyway, Datomic, the most innovative database you've never heard of. So what I want to talk to you today is kind of mostly about Datomic internals, because I believe it's the internals that is the reason for why you've never heard about it. So I would wager that probably 80% of the people at this conference probably haven't really even heard about Datomic. Maybe they've heard about it, don't really know that much about it. In this room, it's probably a little lower, but I would guess there are some people in this room, maybe 20% of you, quarter. It's probably even never heard about Datomic. And the good thing is that I know why you haven't heard about Datomic, because the fact that some people actually use Datomic is a bit of a miracle. Because when you start to read about how Datomic works and what kind of database it's like, it takes sort of a special kind of attitude to not just throw it away as something weird and strange and something from the 70s or something. So let's look into some of the things that we can say about Datomic. So we already said this. Datomic is proprietary, so for most people that's already a showstopper, right? So another one like Oracle or DB2 or Sybase, yay, awesome, right? But if you do somehow get past this point, so you see it's a proprietary database, okay, let's see what it's all about. Then you read things like this. Writes are single-threaded. So already at this point, the people that accepted a proprietary database will sort of just, okay, that's fine, you go on, make your database, but this is nothing for me. Because, you know, it's 2018, right? We have ungendered bathrooms and multi-core CPUs. It's crazy, right? So this seems like it's self-evidently a really, really bad idea to have single-threaded writes, right? There's no, even like the cheapest VPS these days is like a multi-core machine usually. Everything is multi-core these days. So you read it was proprietary, you read it was single-threaded, but you still want to check out what Datomic is all about, and then you read that queries run on the client. Okay. So this is getting crazier and crazier. So what I thought about when I read this the first time was like back in the day when I was even less experienced than I am now. I had like a list of something that I wanted in a database, like a MySQL or something. I started in Rails, actually. I enjoyed Rails in 2004 when that came out. And you have like a list of projects or something, and you want to filter them with a regular expression. And then, without any experience, you'll just select star from projects, and they'll filter them with code, right? And then you learn that that's a really bad idea, because that worked fine when there was 10 projects in a database, but then it grows, and it's super slow. So like this is one of the lessons that all developers learn pretty early on, right? Clearly we shouldn't run queries on the client. They're supposed to run on a database server. Like you should figure out how do we send a regular expression to the server so that the server can run the query efficiently. Okay. So This one is a little bit abstract, but it's also really weird. So transactions are data. What that means that transactions aren't commands, right? Because the way that we usually interact with a database that has transactions is that we open a transaction, and then maybe we read something, and then we write something, and then we read some more, and then we write some more, and then we commit the transaction, and then get various kinds of errors depending on the isolation level, of course, because other people can have written at the same time. But in Datomic, that's not the way it works. Transactions is just a payload of data that you ship to the server. So you can't do like this chatty back and forth transactions. Here's another thing that's kind of weird about Datomic. Datomic doesn't separate data from indexes. And I know it's supposed to be indices in English, but I'm not a native English speaker, so I think I can get away with saying indexes, even though we all know it's wrong. So this when you hear about this, it actually has like a real name. It's actually a real thing. It's called a covering index, which means that the data is actually stored in the index, right? Because many indexes aren't covering in that you use the index to basically find where the row is. And then you have to read the row to get the actual data. But a covering index means that the data is in the index itself. Furthermore, Datomic only has covering indexes. So there's no separate place where data is stored and indexes are stored. It's just the indexes. And there's 4 of them. That's it. You can't create your own index, right? There's 4 built-in indexes where all your data is. Actually 4 times. The data is duplicated across these 4 indexes, or quadruplicated. And that's all there is. You can create your own indexes later on. So it ends up, for me at least, this sort of feels a bit like using like Elasticsearch or something as your main data store. Like you're not supposed to like put data in something ephemeral like an index or a search engine. So this just makes Datomic feel completely like, how can we even use this? Proprietary. It's a single write thread. It's 2018, and it's a single write thread. Client-side queries. One of the first things you learn about database programming, right? You shouldn't do client-side queries. You have these weird transactions that aren't like read, write, read, write. You have to create a transaction payload and then ship it off and have it run on the database server. And then you have this indexing thing, covering indexes. Where is my data even stored? What's going on? What can I do about this? Datomic's a crazy database. So this is why no one has heard about Datomic, basically, right? Because if you're not weirdly predisposed into enjoying this kind of thing, you will see this and then just run away screaming, right? But I found one common element that sort of binds all of us Datomic users together. We do actually have a commonality. So the people that know how Datomic works and actually also kind of enjoy using it are these people. So this is Rich Hickey. He wrote Clojure, the programming language, and Datomic. And this picture is from a talk he made in 2011 called Simple Made Easy. How many have seen that? Simple Made Easy. Yeah, a couple of people. Those are also the people that have heard about Datomic. I can guarantee you that is a 100% correlation. Rich Hickey made this talk, Simple Made Easy, made me super interested in Clojure, seemed like an interesting person. Sort of every talk he has seems, I just find this guy very interesting. So when he started talking about the database, it sort of piqued my interest. What is this all about? And then I saw this crazy list of how insane this database is, but okay, it's Rich Hickey, I trust him, he's done good things before. Let's see what this Datomic thing is all about. But if you don't already have this, then you probably will, as I say, run away screaming from Datomic. But here's the thing. If you are one of these people that see rainbows and stars when you heard Rich Hickey has made it, and you dig a little bit deeper into the trade-offs of and the sort of the implementation details of these crazy things about Datomic, you end up seeing that some of those things aren't actually that much of a bad idea. So that's what we're going to do now. we're going to take a sort of a little bit of a deep dive into the internals of Datomic, because I know trolled you into thinking Datomic is even worse than you probably already thought. But we can get away from that by looking into what actually happens here. So here's the list again. We're going to start to look into this single write thread thing. Because there's been done a lot of research on OLTP databases. And OLTP is like the researcher's name for basically the normal database. Like Postgres is OLTP, it means online transaction processing. So basically any kind of database where you have multiple concurrent transactions, that's OLTP. And the most interesting name I think here is the one to the, for me at least, is the one on the top right there, Michael Stonebraker. How many here have heard about Michael Stonebraker? Yeah, a couple of people. It's good to hear. He has this amazing podcast on Software Engineering Radio where he talks about VoltDB, which is his own sort of database project. And this is one of like the, he's like a hidden hero or something like that. He's one of the architects of Postgres, for example. So this is a bunch of people that really knows their stuff about databases. And what they found was that they took like a database. I don't even remember which one it was, just some kind of embedded OLTP database. And they ran some tests on it. So they sort of invented what they felt was like a natural workload for an OLTP database. And they churned the database through that workload and measured what did it actually do? What did it spend its time doing? This is kind of interesting. It's an interesting way of doing research. There was this really great talk at Strange Loop in St. Louis last year, one of the best conferences ever, from someone at Google. And the way they make decisions about how to like structure their systems is based on research on Lucene. Right? Because these small systems like Lucene and the database they use here, that it's not the exact same database that you are, because obviously Google does not use Lucene for their search, right? But you can actually learn a lot of stuff because it's so easy to probe and figure out what's going on with these small databases. So what they found is that for typical OLTP workloads, 75% of the time is spent doing the stuff you don't care about. That's 75% of the time. That's quite significant, right? Because obviously there's an overhead, right? If there's multiple threads doing things at the same time, there has to be some coordination. So we all know that, right? But like, I would guess that it was maybe 5 or 10% or something like that. But it's actually just 25% of the time in an OLTP database under load is spent doing reads and writes. The rest of the time is spent like moving data around in buffers, managing locks, basically doing the work that's needed to make sure that these threads can write at the same time. So the overhead is immense, right? It's a huge overhead to traditional multi-threaded databases. So this is sort of where the single-threaded writer comes in, right? Because it turns out that a single thread that does nothing but writing can't get a lot of writing done, right? So if we were to do some, I already have a completely unlabeled graph, so we'll now do some napkin math even without a napkin. But basically, what we could say is that if we have a single core, like Datomic can write as fast on a single core as Postgres can do on 4 cores. Basically, right? That's basic. And actually, it's even better than that because this 25% of the time that's spent doing useful work is reading and writing. And as I've sort of implicitly teased, I've said that Datomic has single-threaded writes, not single-threaded reads, which we will get back to later. But Datomic is sort of heavily CQRS, command query responsibility segregation. So the API for reading and the API for writing are completely separate. So that means that this time that other databases spends reading and writing, Datomic spends only writing, and 100% of the time. So what this means is that Datomic has chosen to take a trade-off here. So if you have like a workload where you have to write 10,000 times a second to an unsharded, unpartitioned system, then you can't use Datomic. But it can easily do thousands of writes every second or something like that, continuously. So it seems bad when you first hear that it's a single thread, but when you sort of look into it, you learn that it's not actually that bad. And in fact, this is the performance side of this, right? So it performs better than you might think. But the more interesting part is what other side effects do we get of having a single thread that does the writes. So this means that so in other databases, this yellow area, 75% of the time, you can sort of choose how wrong you want it to be, right? And most of sort of my life, I haven't had to make that choice because the defaults are good enough, but you can choose isolation levels, like if you can read uncommitted, because maybe you need more speed, so you have to allow your queries to read uncommitted data, because having to wait for the commit to finish just makes the database too slow. And there's sort of all kinds of ways to tweak this and get that wrong. And that's, Datomic is basically like a non-issue. I like to call it isolation level 9000. Because it's just this one thread, right, that does the writing. There's no coordination, there's no isolation levels. It's just one transaction after the other, basically, in a queue. Which leads us into sort of the data model in Datomic. Because it's a single thread doing writes, it's sort of self-evidently that there's a single history, like one transaction runs after the other, after the other, after the other, because it's a single thread, right? So this might seem like event sourcing, and that might scare some people. It scares me. I've had to kill projects using event sourcing at least one time in my career, because they basically did what I talked about earlier, right, with what beginners do when we want to filter by a regex. We just select star and do it in our code. Like implementing event sourcing by hand is super hard. So there are some databases that can help you. And also today we have like a Kafka, for example, the Kafka database that can help, because that also kind of looks like this. Like, so what we have here is this red dotted line here is just a single timeline of arbitrary and opaque data. So the system doesn't know what this data is. It's just basically a stream of events. This is what you do in both typical event sourcing scenarios and in Kafka and stuff like that. And then you do this left fold, right? So at least in event sourcing. So what you do is that you start with the first event, and then you're supposed to like return your state. And then you get the next event called with the previous state, and then the next event with the previous state, and then you sort of thread through your state like that. And then you end up with a view. So one of the big problems here is that adding a view when your system has been running for a couple of years can be kind of painful, right? Because then it has to run through all the data from the beginning of time. So I think it's safe to say that like event sourcing isn't like a huge success. There are some cases where it works. You have databases like CouchDB, which just map reduce over something like this. So it works for some cases, but it ends up being like for very performance sensitive use cases, and there's a lot of manual work involved. But Datomic, it kind of looks similar to event sourcing. So in Datomic, you have this thing called facts. We will look more into that later, but that's what you put into Datomic. So you create a transaction, and the transaction is a list of facts, which you just ship to the transactor or the database server. So there's one difference there already, right? So you have this stream of data, but it's not opaque, arbitrary data. It's data that Datomic knows about, right? So instead of having to write this left fold function like you have to do in event sourcing, you just like insert Datomic, like the generic database. You don't have to write any sort of left fold code. And then what you end up with are not a view of your state, but these generic indexes of your state. And here they are. Their names are a little bit cryptic. I won't get into that now, but these are, you remember I mentioned that earlier, right? You end up with these 4 covering indexes of your data. So in a way, I guess you could say it's architecturally similar to event sourcing, but what you end up with is sort of a generic database that you can run queries on. That's the big difference from event sourcing, right? Because in event sourcing, you have to make your own views. Then if you want to query your data in a different way, you have to create another view, and then you have to go through the data from the beginning of time. So it's similar in that you have a single stream of events, but that's basically where the similarities end. So I want to talk a little bit about these client-side queries now. I think even if you're not convinced, at least you can understand why Datomic has chosen to have a single write thread. But these client-side queries, how can that possibly be a good idea? And like the big thing here is that someone has to have the working set in memory. That was, at least for me, that was like the one thing that I had to sort of grok for this to make sense. So what ends up happening if you write SQL or any other sort of traditional database, a server-based database, you have a query language, and you send that query over to the database server. And if you want that query to be any sort of kind of fast or perform in any sane way, you have to have all the data that you're querying in memory. Like you have to have the working set in memory. Because if you have to go to disk every time you want to run a query, it will just be too slow. So that's typically why you have like indexes, right? And those are in memory. That's the thing that's like the working set in that, the working set that the query engine requires, right? And we've already established that it's 2018. There are ungendered bathrooms and multi-core machines, and RAM isn't expensive anymore. Because there's something about the way that we still do databases with like a database server over there, which at least in part is because when we invented databases, hardware was super expensive, right? So this has always been true. You wanted to have the working set in memory, but memory was super expensive. So you had your one expensive server, and that was your database server. And that's the way it had to be. And then your application ran on shitty servers, right? And sent queries to the awesome database server and got data back. But this is obviously not true anymore, right? It's not that memory is free, right? We still have to have performance considerations even today, right? Obviously. But it doesn't really matter that much anymore, right? If the working set is in memory of your application server or your database server, like we don't think like this anymore, right? We just create a server and then say how much RAM it should have. It's not that big of a deal. So the way this works in detail in Datomic is that you have this lazy tree structure. So all of these indexes and the data the query engine uses is based on a lazy and shallow and very wide tree structure of sorted sets, basically. So queries running on the client means that the working set has to be in memory, but that doesn't mean that all the data in your database has to be in memory, right? And that's basically how this works. So you start with this root node in the tree, and it's now red. It means that it's in memory in our client. Then you start running your query, and it's a sorted set, so you basically do a binary search. You start in the middle, and you have to fetch this part of your data, and then it's not that, so you have to fetch that part. This was the right one, so we go down one step in the tree and fetch that part. And then you end up with something, it looks something like this, right? So you have these data structures. There are nested trees of basically encoded chunks of data, and compressed and encoded chunks, that the query engine in the client will lazily fetch automatically for you and put in a last recently used cache. So this is no different from what happens on a database server anyway, right? Most database servers implement their indexes so that the query engine can lazily load what it needs into memory and run queries on it. So the only thing that's really changed when we say that Datomic runs queries on the client is that the query engine is on the client instead of on the database server. Let me cheat. What's my next slide? Oh yeah, sorry. So we have the single-threaded writes, but this model that the queries runs on the peers means that you have infinite threaded reads, basically. So that's one of the trade-offs you get with Datomic as well. There's just one thread that can do writes no matter what, which you get reasonable performance out of, as we've seen, and really good consistency, right? There's no reasoning about consistency at all. It's just one after the other after the other. There's no parallelism in the writes. But then the reads, you can easily like fire up a peer that or a client that runs a query for 12 hours, and it won't affect the writing process at all, right? It's completely separated out. And it won't also, the way it works, actually, it also won't affect other queries. So you can run these isolated long queries, and you can have as many of them as you like, and you're only limited by natural resources, basically. So I also wanted to mention, this is sort of, now we're really getting into implementation details here, but I really enjoy these implementation details, and I wanted to show this because Datomic is very different from other databases, but also in many ways the same, right? So it haven't invented everything from scratch. It sort of relies or borrows from other databases. So how many here have heard of BigTable? Yeah, it's so that's a very sort of real database. It's the one that Google uses to store their crawler data in, so that's obviously a lot of data. It's basically the internet, right? It's stored in BigTable. And one of the things that they found was that there's this data structure that's indexed, so they keep crawling, right? New data comes in, crawling, 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 and they put this data into the database. And what they found is that you can't actually update indexes every time you write to the database, because the indexes are expensive, fancy tree structures that have to be balanced and rebalanced. And there's just so much data being written that there's just not enough time to do that on every write. So there's this concept called periodic merge. And Datomic also does this under the hood. So we've already seen this, like these indexes, these tree structures. And tree structures, as many other structures, are expensive to make, as I just said. So what's good about them is that they perform well, right? So they're all O-log-n, that's their performance, basically the index trees of Datomic. But as I said, they're expensive to write to, so you can't every single time Datomic commits a transaction, it just can't update this tree, it just wouldn't have time for it. So what you have at the same time is this transaction log. So what actually happens when you commit a transaction in Datomic is that just the raw data is appended onto a log. And the log is obviously, it's not just a log file somewhere, it's like an internal database log. So if a transaction is committed, it's written to storage. So Datomic's internal transaction log maintains a list of the transactions that have been committed so far, but not yet merged into the fancy tree structures. So what that means is that every time you run a query, you do this live merge, as they call it. So first the query runs on the index trees, and then it linearly runs through the uncommitted transactions to look at the data there as well. This is called a live merge. And then every now and then, basically, I actually have no idea how often, a couple of times a minute maybe, not sure, the transaction log will be merged into the proper index trees. And this works well because the transaction log is short enough so that just iterating through it works well. So not everything has been invented from scratch in Datomic. Now, this gets into how you use Datomic, because we've mostly been talking about internals so far and how Datomic sort of works under the hood. But this is, the database is a value. What that means is that, so as you probably can guess, I sort of come from Clojure land, and I'm not sure if like the Clojure land invented this, but I mean something very specific when I say a value. So what I mean is basically immutable data. A value is immutable data. So like a mutable hash map, that's not a value because it's mutable. But if it was immutable, it would be a value. And values are equal to other values if their data is equal, value semantics. And for Datomic, the whole database is actually represented as an immutable value. So because of the way these indexes work, let me see, what's my next slide? Yeah. It sort of makes your database functional in a very interesting way, right? Because when you write, obviously that's not functional, right? You send off commits to be written to storage. But when you read from Datomic, you actually get the entire value of the database represented as, like, obviously it's a lazy value, right? Like the indexes themselves. But it represents like a view of the entire database at that specific point in time, which makes your queries entirely functional, right? A query is not something that you send off to a database server and get data back. A query is something you run on a database value. It's a function of your database value. So I thought I'd just show you some quick examples of how that works. First, I'll just go quickly through what you actually put into Datomic. So Datomic doesn't have tables or documents. It has facts. I already mentioned these facts. And the facts, it consists of entity, an attribute, and value. So do anyone recognize this? RDF. Anyone working with RDF? Yeah. It's like RDF, except that there are these two magic yellow fields below here that I won't get into the details about those, but that's what makes it not RDF. But it looks a lot like RDF. So entity, attribute, value. That's a fact. Right, so there's something about if you have an entity and an attribute and a value, you can say Sally likes pizza. That's a fact. And product A's price is now 250, and user X's email is now this. And this is the sort of thing that you write into Datomic. So I thought we'd just look at some quick examples of how that actually looks in code. So here I have some, I told you there will be Kotlin, right? The Datomic is very JVM-centric. So Datomic works well for Kotlin on the JVM, or sort of any JVM language. And I guess the more dynamic the JVM language is, the better. Or not dynamic, but what's the name for it? Manifest types, like Java, doesn't look good when you use Datomic, basically. Type inference helps. Because a lot of these APIs also return like object or an any and stuff like that. So it's a very dynamic system. But what we have here is that we have to connect to a database, and you actually have a version of Datomic that runs completely in memory. So you connect to it, and then you write some stuff. So here we can see db add, that's sort of the function to call. Then we have the number, the 1, that's the entity. And then we have the attribute, that's a person's name, and then the value, that's my name. Then we have another fact, so these are two facts. And what we can see here is that they're both for the same entity, obviously, right? Because the ID is the same, they're both for the entity with the ID 1. So this is how you write to Datomic. So let's move on and see what happens. So as I said, the database is represented as an immutable value. So you don't run queries on a connection. So we connected, but then we have to ask the connection for a DB, and that's the immutable value. So you run queries on this DB value. The query language here is actually, that's another thing that sort of took me a little bit while to grok, because I've never done like Prolog and stuff like that, because it's datalog. It's a logic programming language. So basically what this means, if you sort of, can you recognize this shape here, right? It looks kind of similar, right? You have the entity and the attribute and the value. And since this is logic programming, you basically say that I want to solve for E. So I want all facts where this is true. That's basically what the query means. And what we get back here is a set of sets with the ID of the person that was just inserted. So if you go back to the initial transaction, the number 1 here is that's what called a temp ID. So I can sort of invent IDs and have multiple facts on the same ID, and then the system will turn that into a real ID later, right? That no other objects have. So this is how we've now written to Datomic and read a little bit from Datomic. I wanted to show you how to do an update. So first we have this query on the top here. So there's one difference here. It's that I actually parameterized it, right? So I don't hard code my name into the query. I pass it as a parameter. And then I store, this is how I get like the real ID of my entity back. And then, interestingly, what I do when I update is exactly the same as I did when I created it. So I just say, this is a fact. I should add now that this entity's age is 32. By the way, worst schema in the world, right? We have to do a write every time someone's age change. So probably shouldn't do this in the real world. The write API of Datomic is like deceptively simple almost, right? Because all you do is you just ship these facts off as data to the database server, and it's written. When this becomes really interesting if we move on to the next example, because if I now try to run a query, and this is also the same thing, right? I solve for, I pass in the ID, so E is already solved for it, and I want any fact for this entity where that has an attribute age, and I want that value. And what I get back is 31. That's my old age. While that's charming and all, it's unfortunately not what I wanted here. I actually wanted my current age. So what I have to do then is to ask the connection for give me the latest value of the database. So then I get 32 back, right? Because previously we used DB1. That's the one that I read out before we started doing any additional writes. So this is one of the most powerful features of Datomic, this time traveling feature. So Datomic allows you to do this sort of a la carte, right? Because now we did the transaction, we hold a reference in memory to that database, but you could do things like give me the database as of and a date, for example. And you can read the entire database as of that date and run queries on it, which can sometimes be really useful. Like I like to say that there's actually no databases that have implemented update other than Datomic and a few others, right? Because what happens when you do an update in a normal database? It's actually an atomic delete and create, right? You delete the old value and insert a new value. That's not really an update, right? They're faking updates. Datomic has what I like to call real updates. You actually update, like you add a new age or add a new value. And you can always get a view of the latest data, of course, but you can go back in time as well. And this is when I would, normally, if I were talking to you in my office or something, I will talk about GDPR, which is interesting in this context, but our company's lawyers have advised us to not give advice on GDPR in public, so I don't want to be on record telling you how to solve GDPR and then I get sued later. But there are ways to deal with that. I think that was the last one there. All right, so we've seen a lot about Datomic now. It's proprietary. Unfortunately, I can't solve that. They also have this cloud offering now in AWS, which makes it sort of less relevant that it's proprietary. But I sort of understand. I have that same feeling too, right? It feels weird to install a proprietary database server on my own systems. We just have versions for that for some reason, but that's the way it is. A single write thread. I hope that sounds more reasonable to you now than it did 40 minutes ago. It's not actually that bad of an idea. It's a trade-off. It sets a ceiling to the amount of writes you can do, but it has some really good trade-offs. Client-side queries, which I had to fake that a little bit, right? Because it really means the query engine in the client. But still, when you read about Datomic, it could seem like they have client-side queries, and it seems like a really bad idea. So I want to sort of really get that out of the way. It's not a stupid solution without indexes. It's a proper query engine, client-side. Well, the weird transactions and for covering indexes, I won't have time to cover today. So I guess you'll just have to figure that out yourself. But similarly, they have really good trade-offs that makes Datomic good to use, even though it may sound a little bit crazy on paper. So with that out of the way, thank you very much for your time.